Welcome back. We are kicking off a brand new season, and this time we're focusing on deep learning.
And this is, without a doubt, one of the biggest transformations in the entire history of AI.
It really is. It's more than just making neural networks bigger. This is the moment AI really learned to see, to listen, and to create on its own terms.
Exactly. And for anyone who's been following along, you'll know we built a solid foundation last season.
Right. We covered that huge shift from old school symbolic AI, the rigid rule-based systems, to machine learning systems that actually learn from data.
We talked about supervised, unsupervised, and reinforcement learning. And we also got into the nuts and bolts of ML engineering, the rigor, the evaluation, how you build trustworthy systems.
But the thing with all those classical machine learning methods is that they needed a human guide. We had to do all the feature engineering ourselves.
We had to tell the model exactly what to look for. Think about identifying a cat in a photo. We have to specify things like whiskers, pointy ears, the texture of fur.
We were the ones defining the important patterns. And deep learning came about because we hit a wall. For really complex data, we needed the model to figure out those representations by itself.
And that is the absolute core idea. Going deep just means stacking multiple layers in a network.
So it's not just one layer of calculation?
Not at all. And by doing that, you create this automatic hierarchy of learning. The first layers might learn something very simple, like detecting an edge or a bright spot of color.
Okay, so the most basic building blocks.
The very basics. Then the middle layers take those edges and colors and start combining them into more complex shapes, like an eye or a nose. And by the time you get to the final layers, the network is recognizing high-level concepts. A face, a car, a cat.
All without us ever telling it what a whisker looks like. It just learns it.
It learns it. But here's the big question then. If the basic idea of layered neural networks has been around for decades, why the sudden explosion in the last 10 to 15 years?
That's the real story we need to unpack this season. It's not just one thing.
It really isn't. It's this fascinating convergence of three separate breakthroughs that finally ended what some people called the AI winter.
Okay, so what were they?
First, and maybe most importantly, data. We suddenly had these massive internet-scale data sets to train these models on. They are incredibly data hungry.
Right. Before that, we just didn't have enough examples to teach them properly.
Exactly. The second piece was compute. Training these deep networks is computationally intense. The breakthrough was realizing that GPUs, the graphics cards built for gaming, were perfectly suited for the math involved.
Which made training feasible. It went from taking months to taking days or even hours.
A total game changer. And finally, there were crucial refinements in the algorithm themselves. Little tweaks that allowed us to efficiently train networks with hundreds of layers, which was impossible before.
So that's the journey we're about to go on. Over the next few weeks, we're going to start right at the bottom.
We'll look at how those individual neurons and layers actually work. And we're going to demystify backpropagation. That's the mechanism that lets the network learn, but it's often treated like some kind of magic.
It's not magic, it's just math. From there, we'll move on to the key architectures that really define modern AI.
We'll explore convolutional networks, CNNs, which were the key to unlocking computer vision.
The models that can see.
And then we'll look at recurrent networks, or RNNs, which are designed for sequence data. Think about text, language, and speech.
We'll also touch on some of the more advanced models, right? Things like autoencoders or even generative adversarial networks, GANs.
Yes, the models that can actually create entirely new images, new text, new music. That's where it gets really interesting.
And since this is all built on scale, we have to talk about the engineering. We'll get into optimization, regularization, and how distributed training across massive clusters of GPUs is what makes today's huge models possible.
And all of this connects directly to what you see in the headlines today. The large-scale frameworks, the rise of these massive foundation models that power the most advanced AI applications out there.
So by the end of this season, the goal is for you to really understand that fundamental shift, how AI went from relying on features we defined to systems that genuinely invent their own complex understanding of the world.
It's a profound change. The idea of invention being part of the learning process itself, I think is going to be a fascinating exploration.
Thanks for listening to the Adapticx Podcast. If you have any questions, feel free to reach out to us.